Hello students, in this video we are going to study two topics. First is the heating effect of current and the other is Joules law. However, the second topic, Joules law, is actually connected to the heating effect of current only. So we will start with this one. So what is the heating effect of current? Actually it is a phenomena of production of heat due to the current. As the name suggests itself, हीटिंग इफेक्ट ऑफ करंट मीन्स करंट की वजह से हीटिंग इफेक्ट या करंट की वजह से मिलने वाला या प्रोड्यूस होने वाला हीट. सो हीटिंग इफेक्ट ऑफ करंट इज एक्चुअली द फिनोमिना of production of heat in a resistor. It is a phenomena of production of heat in a resistor by the flow of electric current through it. By the flow of electric current through it. Now this phenomena is called heating effect of current. So actually it is a phenomena that happens in a purely resistive circuit. Suppose we have a purely resistive circuit. Now purely resistive circuit means a circuit which consists only some resistors and a source of EMF, right? So if we have a purely resistive circuit and containing some resistors and a source of EMF, then the energy of that source gets dissipated entirely in the form of heat that is produced in the resistors. Means वो जो source की energy dissipate हो रही है, it all will dissipate in the form of heat energy produced in that resistors. So this phenomena of production of heat energy because of the flow of electric current, through the resistor is called heating effect of current. Now the point is, what is the cause of this heating effect of current? So the most important thing to know is the cause behind this phenomena, right? So we have studied when we applied a potential difference across the ends of a conductor, like we have studied earlier in the videos, that if we have a conductor connected to a cell or a battery, then a potential difference is applied across the ends of the conductor, then its free electrons gets accelerated in the opposite direction. We have studied that, or we can see here also, the free electrons inside the conductor will be accelerated towards the positive end, like this. This will be the direction of free electrons, motion of free electrons, while the electric field that's set up across the conductor will be from positive to negative direction. So these two are in opposite directions. Now these electrons, these free electrons that are moving in opposite direction of the applied field, has some drift velocity, but this drift velocity cannot increase beyond a certain value. They attain a drift velocity because of the force acting on them, but this drift velocity cannot go beyond a certain value. The reason behind this is that these free electrons while moving collide frequently with positive metal ions, and due to these collisions, the kinetic energy that they gain during the process between two collisions, or during the interval of this free acceleration between two collisions, is transferred to that metal ion and they lose that energy. मीन्स ये जो फ्री इलेक्ट्रॉन्स हैं, ये इनके ऊपर एक फोर्स एक्ट करेगा जिसकी वजह से ये मूव करते हैं फ्रॉम नेगेटिव टू पॉजिटिव और एक ड्रिफ्ट वेलोसिटी अटेन करते हैं. बट दिस ड्रिफ्ट वेलोसिटी कैन नॉट बी मोर देन अ सर्टेन वैल्यू. द रीज़न इज़ दैट ड्यूरिंग द मोशन, जब ये फ्री इलेक्ट्रॉन्स मोशन कर रहे होते हैं, दैन दे कोलाइड विद द मेटल आइंस प्रेजेंट इन द कंडक्टर. नाउ जब ये कोलाइड करेंगे मेटल आइंस के साथ, तो जितना भी इन्होंने दो कोलिजन्स के बीच में काइनेटिक एनर्जी गेन किया है, दैट दे विल ट्रांसफर टू द metal ion at the time of collision, due to which that metal ion starts vibrating about their mean position, and this vibrations means this amplitude of the vibration increase regularly. जैसे जैसे collisions होंगे, ये जो metal ion है ये इलेक्ट्रॉन्स के साथ कोलाइड करेंगे, तब इलेक्ट्रॉन्स अपना अटेन किया हुआ काइनेटिक एनर्जी उस मेटल आयन को ट्रांसफ़र कर देंगे, जिसकी वजह से मेटल आयन वाइब्रेट होना स्टार्ट कर देगा. एंड विद इंक्रीजिंग नंबर ऑफ कोलिजन्स, जितनी बार वो मेटल आयन कोलाइड करेगा, उसके जो वाइब्रेशंस हैं वो उतने ज़्यादा वायलेंट होने लगेंगे, या उनका एम्पलीट्यूड उतना ज़्यादा बढ़ने लगेगा. और वी कैन से द एवरेज काइनेटिक एनर्जी ऑफ द आयंस increase. Now this increase in the kinetic energy, of the ions cause the increase in the temperature of the conductor, and because of this increase in the temperature of the conductor, this conductor get heated up because of the flow of current, because जो charges flow कर रहे हैं उसकी वजह से ये सारा process हुआ है. So the electrical energy supplied by the source of EMF, or we can say the current flowing through the conductor, is converted into heat. So how can we write in points the cause? So we will move step by step. First thing, if we have a conductor and we are applying a potential difference across it, means a potential difference is applied across a conductor, then what will happen? Electrons, or we can say free electrons, starts moving opposite to electric field acting across the conductor. Now due to this, electrons attain drift velocity or speed, but this cannot increase beyond a certain value, right? This cannot increase beyond a certain value. ये जो drift speed है ये एक certain value से ज़्यादा नहीं हो सकती. क्यों नहीं हो सकती? The reason for this is that because free electrons while moving undergo lots of collision with metal ions, means collide with metal ions, and during collision transfer their kinetic energy during collision transfer there means electrons transfer their kinetic energy to metal ions. जो electrons इस velocity drift velocity से motion कर रहे थे तो उनके पास कुछ kinetic energy थी. जब उन्होंने collision किया then they give that kinetic energy to metal ions. Now due to this, metal ions starts vibrating. Due to this, metal ions starts vibrating, and जितने ज़्यादा collisions होंगे these vibrations will increase. So at the end हमें क्या मिला? There is the increase in average kinetic energy of the ions. It means यहाँ पर जो average kinetic energy है ions की, it will increase. क्यों इंक्रीज हो रहा है? क्योंकि उनके वाइब्रेशन स्टार्ट्स हो रहे हैं या वाइब्रेशंस इंक्रीज हो रहे हैं बिकॉज ऑफ द कोलिजन्स. अगर कोई रुका हुआ मेटल आइन है देन इट विल स्टार्ट्स वाइब्रेटिंग, और अगर कोई ऑलरेडी वाइब्रेट कर रहा है एंड देन कोलाइड करता है और उसको और काइनेटिक एनर्जी मिलती है, देन उसके वाइब्रेशंस का जो एम्पलीट्यूड है वो और ज़्यादा हो जाएगा, जिसकी वजह से एवरेज काइनेटिक एनर्जी ऑफ आयंस विल इंक्रीज. नाउ दिस काइनेटिक एनर्जी में जो इंक्रीज आया है, इसकी वजह से हमें टेम्परेचर में इंक्रीज मिलेगा. मीन्स दिस एवरेज काइनेटिक एनर्जी कॉज द इंक्रीज ऑफ temperature of the conductor. Means because of this we will get increase in the temperature of the conductor. Now increase in the temperature of the conductor is actually means heating. This actually means heating. So what we can see, due to the flow of charges, due to the electrons जिन्होंने ड्रिफ्ट वेलोसिटी अटेन किया, या इलेक्ट्रॉन्स के फ्लो की वजह से जो हमें मिला, किसकी वजह से है, दिस ईएमएफ सोर्स की वजह से. सो ईएमएफ का सोर्स लगाने से जो इलेक्ट्रॉन्स का फ्लो हुआ या करंट फ्लो हुआ सर्किट के अंदर, उस करंट के फ्लो की वजह से हमें जो रिजल्ट मिला फाइनल, दैट इज द हीटिंग. मीन्स इंक्रीज इन टेम्परेचर ऑफ द कंडक्टर. सो दिस होल प्रोसेस इज कॉल्ड phenomena. This phenomena is called production of heat in a resistor because of the flow of electric current, or heating effect of current. And the reason behind this is the increment in the average kinetic energy of metal ions present in the conductor, right? So this is the heating effect of current. Now what is the application of this effect? So there are some very common practical applications that we see in our homes actually, or in our daily life, that is happening because of the heating effect of current. Out of these all, first very important or very common application is the household heating appliances. Household heating appliances. These machines or appliances are actually based on the this phenomena, heating effect of current. The very common examples of such appliances are electric iron, electric oven, electric toaster, electric geyser, or room heaters, etc. All these works on this phenomena of heating effect of current. So basically होता क्या है इसमें, for every appliance we use a particular resistor, suitable resistor, so that most of the power can be converted into heat. So we try to convert maximum amount of power into heat so that we can use this phenomena. And actually in most of the instruments we use nichrome element. In most of the elements we use nichrome element. The reason behind using nichrome is because it has certain properties. Now these properties are, its melting point is high. Next is its resistivity is also very large. It is tensile, and it is not easily oxidized by the oxygen. It cannot be easily oxidized by the oxygen in air, right? So the reason behind using nichrome element is its melting point is high, so you can heat it more without melting. Its resistivity is large, it can resist more, so produce more heat. It is tensile, it means it can be easily drawn into wires. I mentioned here tensile means it can be easily drawn into wires. And the last is it cannot be easily oxidized by the oxygen present in air. It means it is durable, jaldi kharab nahi hoga, you can use it for a long time, right? The next most common application of this phenomena of heating of electric current is electric bulb, means we can even produce light using this phenomena. So in this phenomena we use a filament, a particular kind of filament of fine metallic wire, generally enclosed in a glass bulb that is filled with chemically inactive gases. Now these inactive gases are like nitrogen or argon, right? So basically, and we can produce light using this phenomena of heating effect of current. So while doing this, we need a filament enclosed in a glass bulb filled with chemically inactive gases. Then the filament material should have high melting point and high resistivity. This filament also have high melting point and high resistivity, so that it can be heated for a long time, so that it can bear the heat for a long time. So when current is passed through the filament, it gets heated to a high temperature and emit light, or we can say it glows, due to which we can produce light. Now most of the power consumed by the filament is converted into heat, because actually the phenomena is heating effect of current and only a small part of it appear as a light, right? So the most of the power is converted into heat and only a small part is converted into light. This is appear as light actually, because that heating of filament cause a glow that we see as light. The next very important application that we use in our households or daily purposes is electric fuse. Now this is very important because it is a safety device actually. This is very important to use because it is a safety device. Now it is a safety device, तो क्या safety हमें दे रहा है ये? It is a safety device which is used to protect these electrical appliances from strong currents. Protect electrical appliances from strong currents. Right now a fuse wire में थोड़ा चेंज है. फ्यूज वायर की रेजिस्टिविटी हाई होनी चाहिए, बट इट शुड हैव लो मेल्टिंग पॉइंट. It should have low melting point and high resistivity. Reason for low melting point is that whenever a large amount of current flow, like due to some short circuiting or because of some reason, अगर सर्किट में कहीं से स्ट्रॉन्ग वैल्यू ऑफ करंट या लार्ज वैल्यू ऑफ करंट फ्लो हो रहा है और हमारा इलेक्ट्रिकल अप्लायंस उतना करंट बियर नहीं कर सकता है, बट वी हैव ऑलरेडी पुट अ फ्यूज़ देयर बिटवीन इलेक्ट्रिकल अप्लायंस एंड द सोर्स, तो क्या होगा कि जब वहाँ से बहुत ज़्यादा वैल्यू ऑफ करंट आएगा तो सोर्स because of its low melting point get melted and break the connection, due to which वो current वहीं रुक जाएगा और appliance तक नहीं पहुँचेगा. So we will design fuse depends कि हमें कितना value का current allow करना है, what is the safety limit. So जब उस safety limit से current increase होगा, then the fuse wire melt and break. So how it works? When current increase from safety limit, then fuse wire melts and break, and because of the break वो जो current वहाँ flow हो रहा है वो वहीं रुक जाएगा और आगे का damage जो भी होने वाला था वो बच जाएगा. We can save the damage of electrical appliance, right? The next topic that we are going to study is Joules law. So for Joules law, to understand this, we consider a conductor AB having a resistance capital R connected such as, now we are considering a conductor AB having a resistance capital R connected to a source of EMF that maintains a potential difference of V across it. So this is a AB conductor having resistance capital R connected to a source of EMF that maintain a potential difference capital V across that conductor, across the and A and B, and a steady current capital I flow in the circuit from capital A to capital B, like this, right, from positive end of the cell to the negative end of the cell. Now this is a purely resistive circuit, and there will be some production of heat as we have studied in the heating effect of current. So what we are going to see, we are trying to find out that amount of energy that is going to dissipate in the form of heat, right? So the potential difference across AB, let's start with the potential difference across AB, V is equal to VA minus VB, right, VA minus VB, and this should be something positive or greater than 0, क्योंकि आपने यहाँ पे सेल अप्लाई किया है, तो VA और VB के बीच का डिफरेंस शुड बी समथिंग ग्रेटर देन 0. नाउ द अमाउंट ऑफ चार्ज दैट फ्लो फ्रॉम A to B in time t is what we are seeing, the amount of charge that flow from A to B in time t, right, Q is equal to IT. This is the charge flowing through the conductor AB in time t, so Q is equal to IT. Now as the charge Q moves through the conductor, the potential energy decreases. जैसे जैसे चार्ज मूव करेगा थ्रू अ डिक्रीज ऑफ पोटेंशियल ऑफ मैग्नीट्यूड V, उसकी पोटेंशियल एनर्जी भी डिक्रीज होती जाएगी. सो लेट्स सी U, द पोटेंशियल एनर्जी विल बी फाइनल पोटेंशियल एनर्जी minus initial potential energy. Final potential energy, like potential energy at point B, minus initial potential energy, or we can say potential energy at point A, right, like charges flowing like this from A to B. तो जो भी आपका चेंज आएगा पोटेंशियल एनर्जी का, इट विल बी फाइनल पोटेंशियल एनर्जी माइनस इनिशियल पोटेंशियल एनर्जी, एंड दिस विल बी इक्वल्स टू क्यू वी बी माइनस क्यू वी ए और क्यू वी बी माइनस वी ए. Now we have considered VA minus VB more than 0, means VA बड़ा है और VB छोटा है, so this answer gonna be in negative. So let it be minus Q VA minus VB and consider it as V minus QV, means this answer will be less than 0. Now if the charge moves through the conductor without collision, if the charge moves through the conductor without collision, then the kinetic energy would change so that the total energy is unchanged, right? So अगर collisions होते हैं तो kinetic energy में कैसा change आने वाला है कि total energy will remain unchanged because of the conservation of energy. So conservation of energy की वजह से the kinetic energy में जो change आने वाला है that must be equal to the change in potential energy in negative, मतलब in opposite. जितना काइनेटिक एनर्जी में इंक्रीज होगा उतना पोटेंशियल में डिक्रीज होगा, और जितना काइनेटिक में डिक्रीज होगा उतना पोटेंशियल में इंक्रीज होगा, सो दैट ओवरऑल देयर एग्जिस्ट द कंजर्वेशन ऑफ एनर्जी. मीन्स बाय कंजर्वेशन ऑफ एनर्जी we have we can write it as k plus u is equal to 0, or k is equal to minus u, or is equal to minus qv is equal to qv, or we know q is itv, right? Now this itv or k is equal to vit is greater than 0, right? Now in this case charge were moving freely through the conductor. So in case where charges were moving freely through the conductor under the action of electric field, their kinetic energy would increase as they move, right? So this increase in kinetic energy, or we can say the kinetic energy gained by the electrons, they will share this energy with metal ions. These ions will vibrate more and more as they get this kinetic energy, and due to this the conductor get heated. This is actually the heating effect of current only. So the amount of energy that is dissipated in the form of heat will be this much amount of energy, right? So this much amount of energy will be dissipated in the form of heat in the conductor in time t. So heat dissipated is VIT, this much joule. Now joule is the unit of energy. Now we can also write it as, if V is equal to IR, then this value will be I square RT time t. I square RT, or if we put I is equal to V upon R, then this value V square T upon R, right? This, all these values are in joule. If we want to convert it into calories, then we have to divide it by 4.18. So H is equal to VIT upon 4.18 calories is equal to I square RT upon 4.18 calories is equal to V square T upon 4.18 R calories. So these are the values of heat dissipated in the conductor in time t. So from the above equations, from all these above equations, actually these equations are called the Joules law of heating. So from these equations what we conclude that the heat dissipated is directly proportional to the square of the current, like from this relation H is equal to I square RT, heat dissipated is directly proportional to the square of the current for a given value of R in time t. The second thing that we conclude is it is directly proportional to the resistance capital R for a given current I, right? For a given current I, like if we see this current as constant, if current is given, then in the time t, H is directly proportional to the resistance capital R. Now it is also inversely proportional to the resistance R for a given value of capital V. If we fix the value capital V, then heat dissipated is inversely proportional to the resistance capital R. Also heat dissipated is directly proportional to the time for which the current flow through the resistor. So heat dissipated is directly proportional to the time through which current flow through the resistor. Like, so from all these equations we conclude 4 conclusions. First, the heat produced in the resistor is directly, let us write first, heat produced is directly proportional to the square of current for given R, right? Second, heat dissipated or produced in a resistor is directly proportional to the resistance for given I. Third, heat dissipated is inversely proportional to the resistance for given V, and heat dissipated is directly proportional to the time for which the current flow through the given resistor. So this is actually the Joules law of heating, and the above equations, these equations represents the Joules law of heating. This was all about the Joules law. So this was all about this video, including heating effect of electric current and Joules law. We will come with another video soon. Till then, study hard and stay safe.